Okay, we're live. Okay, I'm gonna continue my work on building this deep zoom debugger. So this is what we have. We've sort of um, taken the execution history of the program and just laid out each line of code in there. Um, there's various other things to do. One of them is the unrolling of the loop has kind of already been done, but I'm thinking we should probably have the top of the loop be shown multiple times, and also perhaps we can make this canvas bigger so it can see all of the input, all of the output, I should say, without having to implement the panning ability just yet. Although we'll need to do that pretty soon as well. Okay, I think I'm gonna go into the play language and add the code to add another emission of history within the while condition here. Um, they'll get us just a little bit closer to what we need. So if you look at the generated JavaScript file of this fib loop program, you can get a clue about what's going on. And the thing that needs to happen for a what should I say? For the history to be saved is this save function. So perhaps all we have to do is stick this save in here like so. That's an idea. I think so. Yeah. Let's go ahead and do that. I feel like it's probably more correct to put the save after it, but then they'll cause it to return the return value of save. So that's incorrect. So if you really wanted to do that, you would need to save it in a temp variable, saved the evaluation of the condition in a temp variable, and then put it back, and that's getting very gnarly. I don't feel like doing that. I think I'm just gonna put the save. I don't think we have a case where we're gonna do like modification of anything within this line anyway. At least that's my hope. So I'm just gonna that might not come true, that hope, but for now at least I'm gonna just put the save here and call it a day. So I'm gonna need to go into the code generator. Where's the code generator? Okay, so I'm gonna look for a while loop. So okay, so basically I'm just gonna do another save on the line of the condition. Save, and here should be the based on the line of the condition, start line like this. And yeah, if I'm lucky, then that works. I run it. I guess that didn't work. Why would that be? Line of undefined is in the condition doesn't it should be statement.condition because condition is already in JavaScript space, whereas statement.condition is still in AST space. Okay, try that again. Okay, that seemed to like it. Now let me, yeah, now I get this save here, and that's cool. Maybe I don't even need this one. I agree. I should get rid of the other one. I should get rid of this one and only have this, the inside one. I think that would be better. Okay. So now it should have generated another history file, which is that. I'm gonna copy, go over to the other project, delete that one, the original one, and then paste. And there's the new history file. Let's see what happens now. Okay, now I have this while conditional repeated, and that's basically what I want. So the while loop has been unrolled. I probably want to, when it gets to the exiting of the while loop, I probably want to see the closing bracket. But I'm not seeing the bottom of the program yet. So what I'm gonna do is make the canvas bigger, maybe like 2000 height, that I can see more stuff there. Okay, so interesting. This is actually kind of interesting. Yeah. So, all right. One thing about this approach is that I think in one way this is more straightforward to read, but another way it might be, well, this code is not totally the source code that you wrote. So someone like Brett Victor might object to this because they think this is not as close to the author's intention, because there's a transformation applied to the code, to the visual. So that might be true, but I feel like there's an advantage of using this approach, which is that the visual space here is used in a way that sort of matches with the timeline. Yeah, there's pros and cons in here. I would like other people's input on this as well. So if you have an opinion about this, I would like to hear about it. But right now, one thing I would like is to say that, well, if the conditional is false, then it jumps out of the loop. I would like to see the closing bracket of the while loop. So I think I need to go back to the generator and generate a save at the closing of the condition. So perhaps that should be like this. Save statement dot end that line, like this, right after exiting the loop. That should oh, what? Statement is not defined. What? Don't get it. I didn't even start the dynamic variable interpolation. Okay. Alright, let's try it. Alright, delete this file first. We already ran it this, so it should have generated the history file. Copy the history file, paste it here. Okay, try it again. Okay, so now we see this closing bracket to denote that this loop exited. One of the next steps would be displaying the value of these expressions. So like fibnix, well, fibnix is 4 after this statement or something. we see two of these closing brackets. That seems a little off. Let me see if there's an easy way to. I see. Okay, I see. Oh, there's two separate saves before the pop frame and after the pop frame. I see. And that was intentional. Okay. Maybe I just handle it that one otherwise. Okay. Okay. So I handled the unrolling of the loop. I think the next step should be, yeah, or I mean I could, next step, let's do display the value of the variable whenever there's an assignment statement. It's like these. Okay, we'll make another column here in the canvas and we'll display the value of that guy whenever that happens. Okay, I'm actually gonna make slightly more canvas space. Let's say make the width 1200. By the way, I use this trick to get a more for Retina display devices such as my MacBook Pro. The canvas, if you want to increase the resolution of the canvas display, what you do is you render the canvas at double the width and height, and then you scale it back down by half to get the display to be more crisp. So that's the trick I used, and yeah, and this is supposed, okay, this needs to be half of the width, I guess. Canvas dot width divided by 2. And this needs to be canvas dot height divided by 2. Okay. I did not explain that very well at all, but I'm not gonna do all on this because I want to get this thing working. So I'm gonna try to create another column here, and to display the value whenever there's an assignment statement, which I can tell by using the AST. How can I tell actually? How can I relate the line of code back to the node in the AST? I suppose I could just traverse through the AST, use the traverser, and grab that line of code. So in this case, this is like, yeah, I could do this thing. So let me just find line. I had this find function and get source. I'm gonna comment out these lines for now. Oh, my commenting, never mind. Find line. I don't know. Line number. Given a line number, I'm gonna go into the AST and find that. So node, I'm gonna traverse through this AST, and then the traverse function is gonna use my function to visit every node of the AST. I'm gonna say if node dot start that line is equal to the line number in question, then that is the node I want. Found. That's the found node. And I'm gonna return false because I don't care about any other node, and then I'm gonna return the found node. So this function should be able to find the AST node corresponding to a particular line if I'm lucky. What's wrong with the syntax? Oh, not all paths return a value. I intended for it to be that way though. Return undefined. Okay. All right. Set the linter or something. Okay. I don't mind actually. Find line. Okay, find line. There's probably a more efficient way to do that actually. Okay, so then I guess. Oh, the whole reason I wanted to do this is I wanted to know whether this was an assignment statement, and if it is, I want to know the name of that variable that's being assigned to. That was the purpose. So I want to say here, if given this line, AST node find line null, if the AST node type is a what? Is a assignment statement? It's a var assignment. Then it's gonna have a var name. I want the var name. AST node dot var name dot value, and that's gonna be the variable name in question. And now we're gonna go pick it out of the frame, which is in the history entry, because the history entry has a stack frame in it, that one. And let's see, here it has two frames. We're gonna use the one on the bottom, so the last one, entry dot stack, and then we're gonna get the last one. So there was stack length -1. So this is the frame, and then from this frame we want to get the var name. Oh, frame dot variables, I think, because the frame has variables as a sub property, which then will look up the var name based on that. So I'll say value var value. Now, given both the var name and the var value, if it was a var assignment, then we're able to render the value. Render var value if it line is a var assignment. Okay, so if the line is a var assignment, then what I want to do is do this ctx.fill text. The line I want is first var name and then equals var value. But where do I want to render it? The x I'm gonna move it maybe like, I don't know, 500 pixels, and then this is like, basically if the line of code was like here, then I want to move it that way and start like I equals 1 here. So if that was 500, then I mean, I don't know if that's a great value. Perhaps it should be based on the length of the lines in question, but I'll do this first. And then the vertical offset should be the same as that line of code. Let's see if this works. It would be cool if it does. What happened? Oh, we got an error message and it broke everything. Cannot read property line of undefined. Line 53 here, because the node does not have a start. Okay. Okay, if node dot start and the node dot start line is the line number. Oh yeah, kinda. Interesting. Alright, I don't think that we have a problem. We got part of the way there. Okay. That's quite interesting. I'm gonna do 750, and maybe I'm gonna do save the context, and then I'm gonna change the fill color. Style equals peach. Make that a peachy color. No, that doesn't work. Blue. Okay, blue works. That's fine. Okay, so the problem is we capture the state of the variable before the assignment, not after. Oh, I think we can fix that easily by just moving up one entry in the history. So next history entry. Next entry is history I plus 1. So just read it from the next entry. I guess and if next entry exists, then we'll do that to it. And yeah, I think that'll work probably. Yeah, okay, that's actually not bad. So you can, so as a student of programming is reading through this code. Oh, we did have an error later on, but let me just read this first. Okay, so I equals 1 that calls I to become 1. Fib1 equals 1 that calls fib1 to become 1, and so forth. Here fib next equal fib1 plus fib2. The result of this assignment resulted in fib next being 2, and then fib1 equal fib2 resulted in fib1 being 1. Fib2 equals fib next resulted in fib2 being 2 because it got this value, and so forth. And I equals I plus 1 resulted in I becoming 2. It makes sense because I was 1 here. So there's this chronology here that makes sense as you read the code from the top to the bottom. And I like that. This is sort of like, you know, like you're doing, I don't know, you're balancing your expenses report or whatever. There's a chronology here. You read from the top of the page, moving downwards. You can sort of, if there's a mistake at some point, you can sort of backtrack by just looking back upwards to trace what happened. And instead of having to like use the VCR button to walk back in time, I'm not necessarily saying the VCR button approach is bad. It's just that this makes more things visible at the same time. Whereas with that one, you have to, if you are having to sort of interrelate the two different things at two different points in time, then you can sort of have to remember one of them in your head while walking back in time. We got an error message here. Let's figure out what that is. 941. So, okay, in some cases you can't even find the AST node, so I guess maybe to just guard against that. Okay. Okay, so that's step one. I guess step two is, well, here we don't even know what n is, and that's kind of a problem. And the reason we don't know what n is because we never saw this line which defines what n is. We could sort of display, if it's a while statement, if it's a conditional of a while statement, then we could display the evaluation of that statement. And possibly allow them to hover over, although, yeah, adding the ability to hover over something. I guess that's fine. I'm trying to think like what I should add more interactive elements to the user interface other than zooming and panning. Like to be purist about it, I might say you are only allowed to zoom and pan, but Google Earth also allows you to hover over things and click on things and otherwise interact with the map in other ways. So maybe I also allow you to hover over a variable and see the state of that variable at that point in time. That's possible. It could be that I don't bother showing whether this condition is true or false because it is sort of implied, or maybe I could make the user interface sort of imply it somehow. In this case, it's sort of implied because we are it goes into the loop, although there's nothing technically that, other than the indentation, there's nothing that sort of guarantees you that the next line is actually inside the while loop, I suppose. I'm not totally sure about that. Okay. Let me think. So I've done the unrolling of the while loop aspect of it. The next aspect, or another of the main aspects of this zooming interface, is that I want to, when there's a function call, I want to be able to zoom into that function call and then to a level that eventually you can see the code within that function. And in fact, in this case, this should initially be hidden. This while loop code should initially be hidden because initially we should only be able to see this guy. And it's not until you zoom into the details of that fib function call then you see the details of here emerge. So that's the idea. So how do we do that? Let me think. One thing I'm thinking is that, like, should I do a pre-processing step to make it clear, like, maybe I should, because this is a flat array of entry objects here in the history array. Maybe I should make it nested, not flat. Like, maybe there should be a first level object, and that is it has a function name which is gonna be main, and probably it has the parameters as well. For main there won't be any parameters, and then we'll have like history, and these are the history entries. And then we'll have, these are history entries, but some of these history entries might invoke a function call. So maybe this is like type fun call, maybe, I'm not sure. And then if it's a type fun call, then in turn it'll have a fun name. That seems kind of messy to me. How can I tell like what to, because what I want to show, instead of all of this initially, I think I only want to show this initially. Oops. Initially I want to show all of this code, of the body of the main function initially, and then but initially you won't get to see this. It's only if you drill, like you zoom really down into this particular fib function call, then will you be able to see the details of the fib implementation emerge, and then you get to see this stuff. That's the idea. So let's implement that idea. How do we do that? So perhaps the first thing I should do is excuse me. I think the way you can tell is based on how tall the stack is. So if the stack has only one entry and it's fun name, well, you know that's not going to be a line of code that's within a drill down. If it's the stack has two entries in it, then you know we're currently in a drill down. We're currently executing code in a subroutine, a sub function call, right? So perhaps what we do is we filter out every entry that has more than one entry in the stack. That will allow us to end up with only this line. So let me do that first, and then we'll come up with another idea after that. So I'll say if entry.stack.length is equal to 1, or is greater than 1, I'm gonna skip. Continue. Let's see what happens. So yeah, so now we only get to see this line. I do want to show the function header and the function closing body though. So not totally sure how to do that right now. I know how I could do it. But that's okay. Like, how do I find the enclosure, I guess, is the question. I guess to find the enclosure is, like, if your stack looks like this. So in one entry you have a stack of one item in it. If in the next entry you have a stack that has two entries in it. And then the next one you have two. Next one you have two again, etc. And then the next one you have one. You know that these entries are having to do with a subroutine call. And maybe what you do is you look at this line to see what subroutines are being called. In this case it's this one, but also this one. So how do you know which one comes first? Well, this is evaluated. This one's evaluated first. Yeah. You could also look at the fun name that's in here. But there could be times where you have two calls to the same function. Like that. In which case this function name doesn't actually help you. So that's something. Let me think. So maybe what you do is look at all of the call expressions in here, and you kind of have to do within this line, if it exists. Sort of if you find the next line after this line that is of only one stack length, and then you grab all of these and you say that is attributed to one of the call expressions within me. And the way I figure out which one those are is based on the AST traversal depth first, I believe. Depth first traversal of this AST, because this AST is going to look something like print, and then with the arcs, this is very shorthand, so and the arcs is another call, but which is fib with arcs of 7 this time, like that. So the deepest one first, the deepest one is this. So the deepest one should be associated with this set of calls. Should I translate it first so that it's easy, or should I do this translation on the fly? That's an interesting question, actually. If I translate it first, then I have to come up with this intermediate object representation. Then I have to like make sure that's sound and documented and stuff, which is gonna take more work. So is that worth it, or is doing it on the fly better? That's an interesting question. I'm not sure what's the answer to that, but let me think. For now, I think what I'm gonna do is try to do it on the fly. See what happens. So I have to implement the zooming interface, I believe. Something is bothering me. I do want to render this def main on top of the page first. Let me try that first. So I have the est. I had written this find function. Perhaps I'll use that. So I know it's always main anyway, so I'm gonna try. I'm gonna take the first history entry. Actually, I'm gonna make an offset variable. Vertical offset, which is 0. And each time, and this is, I'm gonna do it as like that. And each time, I'm gonna add the code line height to it. Let me see if this works first. That way I can jam additional lines to it if I wanted to. Okay. Why did that happen? Let me undo this. I'm not sure why we got these extra lines in here, so I'm gonna try to debug it. This is I times code line height, right? Oh, because of this continue line. I see. Okay. I could do this line here and here, or I could do it like if you're 1, then do all this chunk. You flip the conditional. Okay, so if I did it this way, then I can use the vertical offset here. That worked. Okay, now I guess I want to say if I is 0, then I was going to actually interject and take the line that is the main function, or whatever function this entry dot stack 0. It should have a fun name. Let me make sure that is true. Let's see the fun name here printed out. No. Okay. Fun name. Yeah, I mean, why doesn't it have a fun name? I don't get it. It has a stack, and then within the stack. Oh, I misspelled fun name. How did that happen? Okay, so that's main. Now I'm gonna do this guy. I'm actually gonna do it dynamically. So I'm gonna get this node, and we're gonna say the fun node has a fun node. The function node has fun definition. Function definition. It has a name. Perhaps we'll just take the first line of the function definition. So that would just be start line, and grab that line. And maybe, yeah. The line is code lines, no -1, and then I'm gonna render that line. ctx.fill text line 0 vertical offset. Yeah. And now I'm gonna increase the vertical offset by the same number, right? That. So this would allow us to interject an extra lines to the equation. Now I have def main, and to do the same for the n, maybe I say if we do the same kind of deal, but except not the starting line but the ending line. Yeah, see if that works. That did not work. Could not find fun. This is undefined. Does the last entry not have a stack? Oh, I see. Okay. So that's interesting. So if the very last entry doesn't have a stack, what I could do is do a make sure everything is in this stack perhaps before it even enters here. So maybe I have entries. I'm thinking of reusing this function for rendering the next, like when we're drilling down to the fib function. So perhaps we pass all of the instructions that will be for the execution of this function, which should not include this one because this one is already done with its function. So for now, I'm gonna do this using a filter. So history.filter. Entry.stack length is exactly, no, I mean it's greater than or equal to 1. So those are the entries. And then I'm gonna loop through the entries instead of the history. Here. See if that works. Did this happen? Last entry. It happened. Did we end up filling the line? Yeah, we got the line and we tried to fill it. Just didn't see it though. Why? Line 16. What's line 16? Line 16 is this line. It has a stack length of 1, so it should have done this. I feel like even we shouldn't have even needed this actually. Alright, what's going on? Gotta do some debugging. Is it rendering line 16? Is it rendering line 15, 12, 15 again? last entry line 16 and then rendering line 16, although none of that showed up. Oh, they were down here. I see. Ah, okay. I shouldn't have increased the offset when we skipped, actually. And so the previous version was right, actually. So if it's greater than 1, we should just continue and not increment the vertical offset so that those lines would get rendered. So this is more correct than before. However, we have double print of let me see, we have a double print situation. Oh, this is line 12, and so maybe I should print the line number as well. So that would be here. So maybe I should do this. Line number and then some space. Actually, I have a separate fill text for the line number. And then this one will be offset by some pixel value. Okay. 100, and then I have to do that here. Okay, 14, 15, and then 12, and then 15. But the 12 is actually, that's that extra thing. It's starting to make me think that I don't want that extra, this extra line here. No, not that extra line. There's this extra history line that has this empty stack, and that's kind of causing trouble now. Thinking maybe I just remove it to make it a little bit easier for me, although let me do that. I'm going to change the generator for the function definitions. I'm not going to generate another save after this pop, and I think that'll make it get rid of that nasty thing that I had to deal with. So delete this history and copy it over again. No, not this one. Delete this history, delete, and copy this one, paste. Okay, so I don't think I have to filter anymore because of that, and also yeah, I got rid of that closing thing. Now it's just that I had this line repeated, which is I did that for the reason of I want the debugger to pause once here, but then and then it goes into the fib function, the details of the fib function. But after it finishes that, it comes back, and I want the debugger to pause here again. So the fact that it does that, I can either filter that out, or I could again get the generator not to generate that code. But I don't want to necessarily break my step debugger either, so I think having a step debugger is still desirable, because especially since this idea is very experimental. So maybe I choose to filter it out. Excuse me. So, but how would I know to filter this out? I actually may want to defer that decision, because I feel like I care more about the zooming aspect of things. What do you think? So this guy is the second occurrence is going to be this guy. And it's again line 15 here, and then up to line 15 here. The point of that is that lines this frame. Okay, so I'm gonna create this concept of the lines in the history that are in this frame by doing a filter of the entries. Stack length is, so I'm gonna have like a current stack height, which stack height is the height of the first entry, let's say. This is the current stack height, and I'm gonna say the lines that are of this frame are only the ones that whose stack height is the same as the entries this frame. And then here I'm actually gonna use entries. I no longer need to do that filtering line. Entries this frame. Let's see if that works. Okay, that still works. The point of doing this filter here instead of inside the loop is that I can perform this filter now, I believe. So I can say if my next entry is the same as me, I'm not gonna bother rendering myself. So I'm gonna say if entry dot line is equal to next entry dot line continue. Oh. There is one case where next entry doesn't exist. Okay, that filtered that out, that line. Okay, I kind of like this. And it's also possible I can move this chunk outside of this for loop. Maybe I do that. The painting of the function header, and this will just be in the initialization of the vertical offset. So this will be 0, I guess. Or maybe you get passed in a vertical offset. I'll say first entry. Alright, let me see. Let me try this. Okay, that sort of works. Okay, so now I'm gonna attempt. Gosh, that was a lot of work. Okay, now I'm gonna attempt to do this zooming user interface thing. That might actually be difficult to do because the math aspect of it is a little tricky. But I'm gonna try to refer to my File Explorer project here at project folder. Okay, so this is the code for my File Explorer project that I published recently. And the code I want from here is the mouse wheel code, which is this. Okay, and also this viewport code. So I also need this concept of the viewport in here, actually. And to kind of bring that in from that piece of code as well. Let me think. That's the playline. Okay, so the viewport, there's a concept of the initial viewport. I think that's important to bring in now. Probably also need this fit text function as well. All of this will need to come in. This viewport variable, it has a top and a left and a zoom level, and we initialize it to some value here. It's right here. Okay. We initialize the top, the left to negative canvas height divided by 2. So, and the zoom level to 0.5. Let me think about that choice. Essentially, we're sort of saying we're gonna render our world. We have a concept of what the world coordinate is, and it may also be actually that initially we render this thing not even necessarily rendering this code here. I don't know. Maybe initially we just render this box that says like main with the parenthesis, and then it's only when you zoom in far enough that you actually get to see this code and the line numbers. So that's possible. There's gonna be a whole bunch of code from the File Explorer project that I may see that we need to bring in to this debugger project. Actually, it might be better, possibly, to kind of sort of like start from scratch and then sort of place the bit that we've done this afternoon inside of that. Although I also do like let me think about this. We don't need the server part. So that's one thing. We don't need the server part at all. This mouse up, mouse move thing. I'm going to take a short break and regroup and think about what I want to do as the next step. But until then, I'll see you later. So I think I'll do one more stream later today. I really hope to get this working, but if we don't, that's okay. Okay, I'm gonna take a short break and maybe come back a little bit later.